Welcome to solverfy.
So this problem is about chlorine gas. We're trying to figure out how much we can fill a tank. So what we know is that we can put in a max of 85 atmospheres, but the actual P that we're going to use is just 80% of that. So if we times that by 0.8, we get 68 atmospheres. We also know the volume, the temperature, and R is of course constant. So for part A, we're asked to figure out how many moles can be put in this tank, but we're actually supposed to use the ideal gas law. PV equals nRT. So we want moles, so let's just rearrange the equation real quick. N equals PV over RT. So if we plug in the 68 atmospheres, the volume, the temperature, and the ideal gas constant, what we should find is that we can put 2,362.5 moles into the tank. Now the next part, we're supposed to find out what the pressure actually would be for this amount of moles using the van der Waals equation. Here, let's make this one a little more colorful, I guess. So for this equation, it's V plus N squared A over V squared times V minus NB equals nRT. So this is basically a variation on the ideal gas law, where this first part, P plus N squared A over V squared, will adjust the pressure to account for interparticle interactions, repulsions, attractions, and all that fun stuff. The second part, V minus NB, will adjust the volume to the particle volume. So we need to find out what A and B are. If you look in your book for chlorine, you'll find that A is 6.49, like a lot of constants. It has some weird units. Atmosphere times liter squared over mole squared. And then for B, it should be 0.0562 liters per mole. So if we rearrange this equation, what we should get is we want to solve for the pressure. So we get P equals nRT over V minus NB minus N squared A over V squared. Now plugging all this in, we know the moles, we know all these other ones, we're just solving for the pressure. We should find that P is actually 30.45 atmospheres. Apologize for my handwriting. So in part C of this question, we're asked, did the engineer fill this up enough? And the answer is just no. The problem with this that she didn't think of when she was using the ideal gas equation is that most gases won't behave like ideal gases under high pressure. That is because the volume between the particles is significantly less, because particles are not massless nor volumeless. They, in fact, have some volume. That's why we have this NB part. And while it's probably not real significant in some cases, chlorine will actually have interparticle interactions, which is what we measure with this part, where we see that because A is much larger, that will actually change what the pressure is. So we see that the engineer would have gotten it right if she just started with this equation, although solving for n squared in that would have been quite difficult, but still feasible. I hope this video helped you all out, and please come again.